This is Algebra 2A, Lesson 3.6, More Function Families. So we have been transforming our linear functions, our quadratic functions, our square root functions, our absolute value functions. We're going to talk about 4 more functions today and then practice doing some transformations on those. The first one I'm going to talk about is we'll do cube function. The parent function of the cube function looks like y equals x to the power of 3. So it's very similar to the square function, right? The quadratic, the power function. The graph looks something like a parabola on the right side, but because when we cube a number, we do have negative outputs with our negative inputs, it's going to basically reflect that other side of our usual up face down, right? Positive inputs give us positive outputs when we cube. Negative inputs give us negative outputs when we cube. It does have that growth, though, where it's going to get faster and faster and faster because when we cube our numbers, they get bigger, faster and faster and faster. The next one is the cube root function. So the opposite of square is square root. The opposite of cube is cube root. Our parent function has a little itty bitty 3 in our root instead of our square root just has the invisible 2 in there. And it is going to be very similar to the square root graph. We are going to have this shape up here because it is the reciprocal or the inverse of the square. But we can cube root a negative value. So we're going to do the same thing in the negative values. So it's almost like the same shape as the cube graph, but he's rotated or turned on his side a little bit. Okay, next we're going to do the, what do you think, exponential? Sure, exponential. Okay, the exponential family is going to be y equals something to the power of x. So a very common one would be y equals 2 to the x. So different than a power function, because a power function, a quadratic, has the 2 as the power, whereas an exponential function has the exponent as the variable, okay? On our graph here, it's going to approach the x-axis for our negative values, but increase for our positive input values. And then the final one that we're going to do is, it's the reciprocal function, also known as the inverse function, depending on who you talk to. They're the same. So I'm going to use those kind of interchangeably, but the reciprocal function, reciprocal, I think it's a no, maybe it's an I. We'll go with it, reciprocal, and also known as the inverse function. Okay, so that is, the parent function be y equals 1 over x. So that is the opposite of a linear function, multiplicative inverse, reciprocal, undoing, right? And the graph for that kind of looks like this one here and this one here. So there are what we call asymptotes on both axes. It approaches 0 as we increase and as we decrease. It can never be 0 because we can't divide by 0. That's outside of our domain. Okay, so we have 4 different graph shapes, 4 different parent functions, and we're going to be applying transformations to these just like our other 4 functions. So here I have a parent function of x to the power of 3, our cube function, okay? I want to consider g of x a transformed function of f of x such that x minus 1 to the power of 3 plus 4, okay? How does that relate to our parent function? And then we're going to graph it. So we're thinking about our transformations. When I see a minus 1 here, that means my x to the power of 3 graph is going to slide or translate 1 unit to the right. And then this +4 at the back tells me that our graph is also going to slide or translate 4 units up. Okay, and I'm going to try to graph that as best I can. So my vertex point, my origin point here, needs to go 1 unit right and 4 units up. So this is kind of where he's going to flatten off, and then he's going to increase like that, and he's going to decrease like that. Okay? Letter B, we'll do another transformation, h of x. I want it to be the horizontal reflection of f of x with a translation right 5 units and then down 3 units. So let's go h of x. We're going to do the horizontal reflection first. If we think back to our horizontal reflections, that means I need a negative in front of the x. But specifically in front of the x, right? Oh, sorry, forgot something. Forgot to do my horizontal translation. Then we're also going to go right 5 units. So I need a -5 before my power 3. So it's just like the quadratic, right? But with the power 3 instead of the power 2. And then we're going to go down 3 units. And then we're going to graph that. So I need to go right 5. 1, 2, 3. Oh, we're going by 2s. My bad. I messed that up on the first one, didn't I? Okay. 2, 4, 5. 2, 3. So here's where my function is going to be centered. But because it's a horizontal reflection, we're going to flip him down moving forward and up moving backwards. Write an equation for the function, letter B. So we have some pictures. We're going to try to write some equations. First one here, if I'm looking at the shape of the graph, it's similar to the cube that we just did, but he's turned a little sideways. He's more like the cube root function. Okay? The standard cube root function is centered on the origin 0, 0. And I can see this one moved over here. So we're going to translate this. It looks like 4 spaces to the left and 2 spaces down. So I have my cube root function. We are going 4 spaces to the right and 2 units down. You can add these parentheses here if you need to, but remember wherever the line stops is indicative of where that close parentheses should be. Okay, and letter B, I'm looking at the shape of this graph. I'm considering my parent functions, and he looks like the reciprocal, also known as inverse function. So we're going y equals 1 over x. Then we're going to slide it. Normally, our asymptotes would be right at the origin, but I can kind of see that I have one here and I have one here, so I need to translate my origin point 2 units to the right and 4 units up. So we're going to go y equals 1 over. The unit translation to the right, the horizontal translation, needs to go by x. So we'll go x minus 2 to go to the right. And then the vertical translation is always at the back of the equation, full-sized plus 4 at the back. Okay. I do have my calculator here just because I want to check my equations, see how good they look. So I have the cube root special function built in there, the cube root of x plus 4 take away 2. Oops, I'm not used to this one. I gotta use the arrow to get out. There we go. Take away 2. So like I said, x plus 4 in the parentheses, also where the bar stops, minus 2. And if I hit graph on that one, kind of slide him out of the way a little bit, I can see that same shape right here that mirrors this one right here. Okay? And let's try the letter B graph. Slide him back out of the way. Y equals, I'm going to clear that off. We are doing 1 over x minus 2. I'm putting that in parentheses to show that it goes with the x, plus 4. Oh, I can tell something I forgot to do. So the graph that I have here is over here, right? And so to reflect my graph, I need a negative. Okay? Let's try adding that negative in there. That looks better. So our graph slid 2 units to the right, 4 units up, and it also reflected. And I would call that done. That is it for this video. Good luck on the exercises, and please let me know if you have any questions.